to go through it, make it a lot simpler so that I could understand it. And then, I really enjoyed the process of making this presentation so that I could make it simple and interesting for all of you as well. So hope you like it. Let me start. Okay, so setting the stage. So we are really going to quickly talk about some concepts about Vedas and science, a little bit then about AI and data, what I see as the perils of AI from my experience as well as from Mama's writings. And then we'll kind of have a case for collaboration of AI with Vedic wisdom. Okay, the interesting part starts with, do we really understand the universe? How much of the universe do we know and understand? Because there's so much happening. It's so immense. It's so mystical. So these are a few things that are part of Mama's writings, which I've condensed and tried to explain through some videos and some slides. So let me start with, if I quickly go through these, you will resonate with some of these, infinity, symmetries, quantum physics. Just wait, just hold on. It's a little tricky, but fortunately, I was able to find a simple enough video which kids can understand. So hopefully, all of us should follow that. And then we'll talk about a few more things. Infinity. Very interesting. So if you look at this picture, you will see the center of this picture, which really depicts what is the visible part of the universe, which can be perceived through our senses. So something, from the human vision up to what the microscopes and the telescopes can reach. And you will realize that it's not too much. It's not a huge amount that we can really visualize. There is so much beyond. So to your right, it's the size of the observable universe and the other universes. It goes far, far beyond of what even the most advanced science has been unable to even, use technology to visualize or, to perceive. The same thing goes on the left, where you have the microscopes have not been able to, go and visualize the details of what lies in the beyond the subatomic levels, and and then we go up to the string theory. So it's called the visible part is called the pratyaksh. In Vedic literature, it's called the pratyaksh, and the invisible part is called the proksh. Let me move on. This gets a little more interesting, because this kind of continues from the infinity concept and symmetries within symmetries within symmetries, and it goes on and on and on till infinity. So understand that nature is infinitely symmetrical, and the origins of this are really in a concept called rhythm, which originates in the Rig Veda. And you will realize that, you will notice that it rhymes with the word rhythm. So rhythm and rhythm, that's where it originates from, the word rhythm. And I'll quickly jump into a video which will explain to you how these symmetries really work from the microcosm to the macrocosm, from the tiniest of atoms and subatomic particles to the immense vastness of the universe. So let me jump into the video right away.
What do galaxies, cloud formations, your nervous system, mountain ranges, and coastlines all have in common? They all contain never-ending patterns known as fractals. A classic example of a fractal in nature is broccoli. in that the whole stalk is a similar version of one of its branches. So cut off one piece and you're left with a smaller version of the entire broccoli. Snowflakes are another example. It's often said that no two snowflakes are ever the same, and fractals offer a fascinating explanation as to why nature works in this way, why nature continuously creates new, self-replicating, yet unique structures, and how the smallest things in existence are necessary components of the greater whole. The term fractal was coined by Benoit Mandelbrot, who was working at computer giant IBM in 1980. Mandelbrot had been fascinated by discoveries of mathematicians from the early 19th century who were attempting to define their understanding of what a curve is. Experiments such as George Cantor's discovery that a single line could be divided forever, and Helga von Koch's triangle, a shape that has an infinite perimeter but a finite area, resulted in the term monsters. Mandelbrot used the modern computing powers developed by IBM to run these monster equations millions of times over. This process led him to a breakthrough equation combining the patterns found in previous monsters, resulting in his own set of numbers. This would become known as the Mandelbrot set, an infinite geometrical visualization of a fractal. One of the most amazing things about the Mandelbrot set is that theoretically, if left by itself, would continue to create infinitely new patterns from the original structure, proving that something could be magnified forever. Fractal geometry is currently applied in many fields, for example, research into climate change and the trajectory of dangerous meteorites, helping with cancer research by helping to identify the growth of mutated cells. It's even believed by some that the universe itself may be a fractal, and as you zoomed in, discover it made up of billions of galaxies. Inside of those galaxies, you would find trillions of stars and billions of solar systems and planets. And on one of those planets, you would find Earth. On Earth, you would find continents, cities, and a human. And inside of that human, you would find a brain made of millions of cells in which you would find trillions of synapses firing. And inside of those, you would find DNA. Inside DNA, you would find atoms, electrons, protons, neutrons. Deeper still, you would find quarks, neutrinos, and so on. And then, just maybe, continuously deeper into infinity. Some believe that due to their highly complex and mysterious nature, the greatest use of fractals is yet to be discovered.
Okay, let's move on. I hope that gave you some insight into universe, symmetries, and infinity. Okay, this, I told you, hold your breath for quantum physics, because this is the tricky part. This is the, yeah, I would say this is the most complex part of this, this session. But don't worry. I mean, if you don't follow it, it's okay. Just get a feel for what it is, and yeah. It's essentially, we're going to be talking about the duality in nature, that matter, energy, particle, wave, logic, emotion, male, female. These are all the different examples of duality in nature. And quantum physics itself is, it's the study of the minutest, the completely subatomic form of physics. So it talks about duality of particle and wave. So I'll quickly show you a video about that, and yeah, you'll get some perspective.
What quantum physics is. And if you don't feel bad about it, raise your hand, own your ignorance. It's totally fine. Okay, right. So quantum physics is the description of the smallest things in our universe. So if you zoom right down, smaller than cells, down to the scale of molecules, atoms, and things atoms are made of, the subatomic particles, protons, neutrons, electrons. And it's describes how they all work and also how they interact with light. And the interesting thing about quantum physics is it's like the fundamental rules of the universe. And yet, the things that happen there are so very strange. So I'll tell you a few of the phenomena that go on in quantum physics. One you might have heard of is called particle-wave duality. So you can imagine all these subatomic particles, these protons, neutrons, electrons, like little bouncy balls, kind of bouncing around, bouncing off each other. But sometimes you have to treat them as like spread out waves. And they kind of do both at the same time, which is hard for us to imagine. So I'll paint a picture. Imagine dropping one of these bouncy balls into like a pond, water. The ball would disappear, and then you get these ripples going out over the surface. Now imagine one of the ripples hits, say, a stick. All of the ripples on the surface disappear, and by that stick, suddenly a bouncy ball pops out again. That's kind of strange for us to think about, right? But this is the kind of behavior that goes on in the subatomic realm all the time. Another phenomena you might have heard is called quantum tunneling. So imagine I'm throwing one of these bouncy balls against a window. So it'd be like bounce, throw, bounce, catch. Throw, bounce, catch. Throw. It's gone completely through the window. It's not smashed it. It's not interacted with it at all. It's just suddenly on the other side of the window and you can see it flying away. If we saw that, we think it was crazy, right? But this goes on at the subatomic realm all the time. In fact, it's the only reason we exist. So you might know that in the sun, the way it generates energy is through nuclear fusion. And nuclear fusion is when two hydrogen atoms come together and the protons in their nucleus bounce off each other. Now, if it wasn't for quantum tunneling, they'd bounce off each other and nothing would happen. What actually happens is they quantum tunnel into each other. And that's what lets them fuse and release the sunlight. And without sunlight, we wouldn't exist. So we can thank quantum tunneling for our existence. Another phenomena is called superposition. And it's a very fancy word, but all it means is something that can do opposite things at the same time. So, for example, I can spin around one way, I can spin around the other way, but what would it look like for me to spin around in both directions at the same time? We can't do that. We can't imagine that. But this is what these subatomic particles do all the time. And in fact, we can kind of do it. At least bits of us can. So if you've ever been in an MRI machine, what an MRI machine does is it finds all of the hydrogen atoms in your body and makes them spin around in both directions at the same time in this superposition. This is what allows us to see inside people's bodies. So it's interesting that all of this physics seems so kind of abstract and remote from our everyday experience. And yet it's happening inside our bodies. We're made of quantum stuff, so it's happening everywhere around us. And it's not just MRI machines that we use like quantum physics for. There's been a whole host of other technologies that come about because of our understanding of quantum physics. So one of those is our understanding of silicon allowed us to invent the silicon chip, which is in every single computer in the world. So the entire computing infrastructure of the world exists because of our understanding of quantum physics. And it's in other things like lasers, they're quite useful, and nuclear power plants. And there's this other soundbite you might have heard about quantum physics, is that no one really understands quantum physics. Well, that's actually wrong. We do understand quantum physics very well, and you'd kind of hope that we did if it forms the technology of MRI machines or nuclear power stations. What they mean when they say that is that when we try and picture in our heads something that can be both a particle and a wave at the same time, or something can spin around in two directions at the same time, we find it very hard to picture that in our heads, but we can describe it all very well using mathematics. So it's fascinating that something can be so counterintuitive on one hand, but yet can be so practically useful on the other.
Okay, I hope that gave you some perspective. It was the easiest way I could get you to understand a little bit of quantum physics. Some of the engineers might follow, but for the others, I hope you got a slight understanding of, the particle wave duality. Okay, we'll now jump into a bit of AI, a quick look at AI, and then we'll come to the collaboration between AI.
What do you mean? What do you mean by AI? Can you just explain?
What
Full
I
form of it.
artificial intelligence. Sorry, whose question was that? So, okay.
Nitin asking.
Yeah,
Just,
Nitin,
just the full form, yeah.
AI is artificial intelligence.
Yeah, we are all artificially intelligent, so yeah, we got it.
What did you think, Nitin?
He thought some Bombay lingo you're calling him AI.
I was just asking the dumb questions for people who are shy to ask the question. So if you don't know what AI is, then whatever you're going to talk after that makes no sense.
It's
Yeah,
not Air India, by the way.
It's not Air India. Okay, makes sense. Makes sense, Nitin. Yeah. Okay. So here's the interesting part about nature and AI, where there's some symmetry or similarity between them. Just yeah. So look at carbon and silicon. Nature is essentially about carbon, the carbon bonds and the symmetry of life, and natural intelligence is all based around carbon. So bit of chemistry here, but keep that in mind. It's going to be something that you will connect the dots later on. And also the relation between carbon, silicon, nature, and AI is something that was very, very well brought out in Mama's writing. So I thought maybe quickly I will just have a slide on that. So we did see silicon in talk about silicon in the video about quantum physics, but understand that the entire the semiconductor industry is based around the silicon bonds, and that's where artificial intelligence also emanates from. So AI, artificial intelligence, and data. To keep it very simple, AI is there are really two things here. There's an AI algorithm or a model, and it is trained on data. The more data there is, the higher quality of data there is, the better that model is. Very simply, that's all we need to know, and in order to connect the dots later on. So let me move on. Notice that AI is getting bigger and bigger as we speak. But is it infinite? Can it reach infinity? We'll talk about that. Till now, what we see about artificial intelligence, that it is getting huge, but it is still finite. So there are some numbers here. You will see that the data for artificial intelligence has reached petabyte scale. A petabyte is a number which is got 15 zeros after it. It's a huge number. So data is huge, but still finite. The parameters that depict the size of an AI model are also huge, but again, they are finite. So we'll connect the dots later when we talk about the universe and AI together. So we revisit infinity here, and you can, this is a diagram we looked at earlier. And the perspective to take from this slide is that data for AI is limited by human perception and senses, because where did the data really come from? The data has been gathered from all the human sources, all the human knowledge, all the literature that is created, has been created by mankind. So the data for AI is absolutely limited by the human perception and senses. So it is growing, it is huge, but it is still limited. What is the promise and the perils of AI? So the promise of AI was that it'll or still is, that it will enhance human capabilities. It will be able to solve global challenges, enhance productivity and innovation. Lots more. The main ones I have covered. What are the perils of AI? Huge amount of energy consumption, because these models are getting so huge. The data processing is getting so huge. They need to consume a lot of energy. There are inaccuracies. There are harmful things like hallucinations, bias, and ethics. We don't understand what happens under the hood, what happens behind these AI models. They are so complex that they even the inventors or the creators of those models, they do not understand what happens underneath. So it's still not explainable. And then we have these other problems that we are all aware of, the job losses, and there's more. Where does AI stand today as we speak? So there is a power race. There is an absolute mad rush to build the most powerful models. They're spending trillions of dollars, and they're spending huge amount of gigawatts and more of power plants being built to support all these initiatives. So the question that comes to mind is, what about the initial promise of AI? What about responsible AI and ethics? We'll talk about that as we move ahead. So let's move on to Vedic wisdom. So this was another very interesting part of the chapter that I read in Ravi Mama's book. So energy returns in three forms. There are three Shaktis. There is the Lakshmi, that Lakshmi is the energy that diminishes by giving. So it's typically money, and there are other forms, but what we most relate with is money, that by giving money, it diminishes, it reduces. Usha is energy that replenishes itself. Examples are sunlight, a flowing river stream which replenishes itself, the leaves in a tree, they grow back. And then there is Saraswati, which increases by giving. So there is knowledge, there is love, and there are various other forms. So this was very interesting when I came across this, that, that this was quite a revelation to me, that, there is energy that, can, increase and replenish. And it's so interesting. Yeah. So we really need to learn from the plant kingdom. And this was highlighted really well in the chapter, that if you learn from the plant kingdom, it really balances all these Shaktis. It embraces the concept of sustainability in the universe. The plant kingdom, the plants, in the forests, they live symbiotically with fungi, insects, and birds. They seed the rainwater, evaporation. There's that entire life cycle of sustainability happening around that. And then nurturing back oxygen from carbon dioxide. So again, really need to learn from what's happening, within the plant kingdom, the forests, and nature. So this is the form that really represents the universe on a smaller scale, and that's why it's called Brahman. Let's move on to a quick conclusion. So what must we really do? How do we take this challenging situation where we are confronted with AI, with the perils of AI? How do we deal with that? Or what Vedic wisdom can help us with that? So here they talk about dharma, and that in this context it relates to responsible AI. So let me read these out. These are excellent sayings, which would be good to read verbatim. So it says, we must control AI very sensibly and painstakingly. spread a philosophy of humanism, so that, in the words of Rajiv Malhotra, who's one of the co-writers, the people who are anchored in dharma have a more cultivated conscience, a deeper and more vibrant awareness of the consequences of their actions, and they are less likely to be swayed by kama atharva based temptations. So essentially, dharma, which means our moral duty, our ethical responsibility, is if we are anchored in that, we would be able to take, the right decisions. And really, it's our leadership which needs to be anchored in dharma. Moving on, in handling AI, therefore, we must heed the warning of Rabindranath Tagore that a mind which is all logic is like a knife all blade. It cuts the hand that wields it. So remember that, where does this come from? The important word here is logic. So think about it. Our logic stems from our understanding, our perception, the limited perception that we have. Whereas the universal consciousness goes beyond, goes till infinity, right? So the intelligence in the universe, it extends beyond infinity, whereas the human logic, the human understanding is limited to the perception we have, and even science is limited in its perception to certain limits, as we saw in the infinity slide. So again, a mind that all logic is like a knife all blade. It cuts the hand that wields it, right? So that's quite profound. So where do we go with this? We conclude with making the profound statement that artificial intelligence should be tempered with true wisdom. Open to some questions from you, because it was, I think, a lot of information, but a few quick questions, and then over to you, Sajil.
First, I just want to say a couple, Amaya, excellent effort by you to bring together a lot of what Ravi Mama spent about decades of his life researching and writing about. And hats off how you've done this for the family to get just a concise view. I think this is so deep that, it's actually touched at least me, and I'm sure many others on this call at a level beyond where our mind, right? It's touching our spirit. So really thank you for what you've taken this initiative to do. I think Mama was way beyond his time. He had these insights about AI, which we're just seeing today in reality, but he was talking about these 25 to 30 years ago. So hats off to what his brain was, and I'm sure it's still in his vibrations, and the way you actually captured and explained it to all of us. So thank you for that. No more question on my side.
Yeah, it was a very interesting journey for me to read up on his writings, and then to try and condense it, search for some videos that could explain things in really simple in a simple form, like it would explain to a 10-year-old. So it was interesting for me, and I really enjoyed it. And trust me, I'm going to go back a few slides and tell you what I felt. So I actually experienced this, I experienced this energy of, that the energy increases by giving. And this is what I experienced with this Saraswati Shakti, that, I can really give back, and at the same time, I can feel it increasing within myself. So thanks for listening and bearing with me. I hope you all are going to take back some insights from this. Thank you for listening.